Hello dear students, in this video we'll continue the other chemical properties and we'll solve the in-text questions of this group of 15. Okay, so the next important chemical property of this group 15 element is that is reactivity towards the halogens. So these group 15 elements, nitrogen, phosphorus and the other element, no, up to bismuth. So what they will do is they will react with the halogens to form mainly two important compounds, that is the trihalides and the pentahalides, that is EX3 and EX5. So here E can be the element of group 15 here. Okay, so out of all the group 15 elements, no, the nitrogen atom it will not form a pentahalide, that is nitrogen do not form a NX5. Okay, so the main reason why there is no formation of this NX5 is, you know that the nitrogen can form a maximum of 4 covalent bonds. Okay, so more than that it cannot form, one thing. The second reason what you can give here is, one more reason is the size of this nitrogen, it is very small compared to the halogen. So that is also one of the reason why these trihalides of nitrogen, why they are highly unstable. Okay, so remember it do not form an NX5, so there is no availability of d orbital. That reason also you can consider there. Next one is the pentahalides are more covalent compared to the trihalides. That means if you consider here PCl5 or PCl3, NCl3 or the NCl5, no, so what it meaning of this sentence is the pentahalides are more covalent than the trihalides. So as you have already learnt that how the covalent bonding is formed. So the main thing is, in order to form a covalent bond between these molecules, no, this bond is formed by a sharing of an electron. The simplest way how you can remember here is, for example, I am saying that pentahalides are more covalent than trihalides. So PCl5 and PCl3 I have considered here. When we write the oxidation state of this phosphorus, it is what? It is +5. When we write the oxidation state for this that is phosphorus trichloride, the oxidation state for this is +3. So the simple way to identify which is more covalent than the other is, check the charge. The more electrons here the less electron, that means more electrons are being shared. So if any bond, if it is formed by the sharing, then we call it as a covalent. That is nothing but a covalent nature. Or else, you have learnt this in the chemical bonding, that is Fajan's rule. According to him, you can also explain this covalent nature. So what does it say is, according to him, there is a increase in the charge. If you consider that, if there is a greater charge on the cation, no, so then that, what does it mean is, that particular thing is having a more polarizing power. Okay, greater the charge, greater will be the polarizing power. If the polarizing power is more, then it is nothing but what? The molecule is more covalent. That's it. Okay, so you can remember this thing here. See, if there is a more charge, increase in the charge, that is directly proportional to what? Polarizing power. If there is a more polarizing power in the molecule, then it will be more covalent. So you can take a note of this. It is very, very important. Covalent nature of the molecule, no, it is directly proportional to what? It is directly proportional to polarizing power. If the polarizing power is there, so this polarizing power is directly proportional to charge. So in order to identify the covalent nature, just check the charge. Greater the charge, greater will be the covalent nature. Okay, very, very important. According to this, or according to covalent nature also, that is more electrons are there, more electrons are being shared, so it is covalent. That is very simple way to remember this. Next, there is one exception that you have to remember here is, except nitrogen, no, all the trihalides are stable. That means if you consider PCl3, or if you consider SbCl3 or arsenic trichloride. So when we consider all these, no, nitrogen trihalides, that is NCl3, they are not at all stable. So what is the main reason? We'll see that but the exception is out of all that only NF3 is most stable. So what is the main thing here is, you can see here when we compare the size of this nitrogen with the phosphorus, Sb and arsenic, no, the size they are little more, that means they are having more size compared to nitrogen. When we compare the size of this nitrogen and any halogens here, like it may be Br, Cl, okay, or the I, what happens here is there is a difference in the size. As a result, what happens, you are making them to bond to form that molecule, no, the difference is very much high. As a result, no, that will cause the unstable. That will be the main reason why the trihalides for the nitrogen are very much unstable except NF3. Why here NF3 is stable, you can easily explain here. When we compare the halogens like Cl, Br and I, the size of this F is very less. So there is a stability that will be taking place here. So you have to remember. So what is important here is, in this cases, in the case of reactivity towards halogen is, they will form a trihalides and the pentahalides. The pentahalides are more covalent than the trihalides. What is the reason? Because of the increase in the polarizing power. That will cause the increase in the charge. Okay. So what is this polarizing power is nothing but the capacity of this any cation to attract to the negatively charged species. That means here this is a positive ion. If you consider phosphorus or the nitrogen, if you consider, that will attract this negative charge. So how much it is attracting towards itself, that will indicate what the polarizing power. The more polarizing power, that means it is more covalent in nature. Okay, so that those things you have to remember. And then except nitrogen, all the trihalides are stable. Only NF3 is most stable. This is all about what reactivity towards the halogens. The next chemical property, that is reactivity towards the metals. So these group 15 elements, no, when they react with the metals, they form what respective compounds. That is, for example, I have written here, whenever calcium with the calcium metal, if the nitrogen is reacting, there is a formation of calcium nitride. How to remember? You have learnt it already. The valence of this calcium 2 plus the nitrogen, that is -3. So Ca3 N2. There is exchange taking place. So this is called as calcium nitride. If you consider here phosphorus, then there will be a formation of calcium phosphide. Okay, like that the respective compounds will be formed. So all of these like nitrogen, phosphorus, arsenic, antimony and bismuth, all of them have what? -3 as their oxidation state. So with the metal, always of the pattern like this they will be formed. Okay, like calcium nitride, calcium phosphide, like that. So this is about the reactivity towards the metals. Now there are few questions that they have mentioned in your NCRT. Like we will solve them. Okay, they are very important text questions. The first question is, though the nitrogen exhibits +5 oxidation state, okay, it does not form a pentahalides. Give reason. Though the group 15, there is a possibility of showing the +5 oxidation state, but why it is not forming NCl5 or NBr5? So the main thing here is, okay, the hint I have mentioned, I have already explained you the reason for this. N is equal to 2. That means what? N is equal to 2, S and P orbitals are present in this nitrogen. It cannot expand its bonding for the pentahalide formation. There is no availability of the d orbitals, only S and P orbitals are present. That is why it cannot form a what? It cannot form a pentahalide. So what reason you can give here is N, the N value here is 2, only S and P, and it cannot expand its covalency to the 5 bond there. So that is why it will only restrict to the lesser compounds, not the NCl5, that is, or NCl5 or the NBr5. That is the answer for this. The second one is, Ph3 has a lower boiling point then NH3. So in the previous video we have learnt the boiling point and melting point in learning about when we were learning about the physical properties. There the pH3 was having a lower boiling point compared to the NH3. So the main hint what you can hear is obviously there is a hydrogen bonding taking place. Nitrogen, which is electronegative atom, so one electronegative atom, and if hydrogen atom is present, so then there is a hydrogen bonding taking place, that is intermolecular hydrogen bonding taking place. As a result, what happens is the bond will be strong. We require more amount of energy to break that hydrogen bonding. More amount of energy means what? We are supplying more heat in terms temperature. So higher temperature, that means higher boiling point. So in liquid state, NH3, which is showing a intermolecular hydrogen bonding, than pH3, that is why. So there is a difference in the electronegativity between this N and H, that is why N shows the hydrogen bonding. So that is a reason. Okay. So few other questions they have mentioned here, that is 7.1 and 7.2. Let's see that. Why pentahalides are more covalent than trihalides? So easily you can answer this question. Why pentahalides are more covalent? For example, I have written the example here. PCl3 and PCl5. Very important if they ask you to write them in the increasing or the decreasing order of their covalence nature. First thing what you have to do is very simple. What I here they have explained you like why there is more covalency and less covalency in the NCl3 or the PCl3. So in order to identify it in a very quick way, just identify the oxidation state for this central atom here. The one which is having more, that will be more covalent. For example, this is having +5, this is having +3 here. So then this will be having more covalent nature. Okay, because the covalency character is directly proportional to polarizing power. The polarizing power is directly proportional to charge. Okay, so indirectly if you identify the charge, that is directly proportional to covalent nature. Okay, so very important. This is the answer for your 7.1 in text question. Next, 7.2. Why bismuth hydride, that is BiH3, is the strongest reducing agent amongst all the hydrides of group 15? Like for example, group 15 elements NH3, PH3, they when they react with the hydrogen, there is a hydride formation taking place. But what the question says is why it is acting as the strongest reducing agent. So NH3, PH3 and other elements, when we compare that with the bismuth, now you know that all of them have got -3, okay, oxidation state or the charge you can consider. So what happens is you also know that down the group, no, that will be what? That will be decreasing. Okay, so that will be decreasing. That means this BiH3 is very much unstable. That means the stability of this is very less. So when it is highly unstable with this -3 oxidation state, what it wants is it wants to get its stability back. So in order to get that, it will reduce the other. Okay, it will reduce the other and then itself undergo oxidation. That is why it is acting as a strong reducing agent. Remember, how you have to remember here is based on the stability factor of this with respect to the oxidation number. It is highly unstable in the -3 oxidation state. As a result, what happens? It will reduce the other and itself undergo oxidation, hence act as a strong reducing agent. So they may give you like this also, which among them will be the strong reducing agent, or increase them. In your entrance examination, they will give you the options. For your board examination, how do they use? Give reason type question also. For 2 marks, they may ask you why BiH3 is a strong reducing agent, or arrange them and give reasons. That kind of a questions also you may get. Okay, so this is about the chemical properties and then these in text questions.